All right, so we have a new style of teaching today. It is co-teaching with your usual teacher, which is me and Miss Franks, who also knows what she's doing in chemistry. So, you need to find this slide that you're looking at in your notes, and you're also going to need your periodic table out. So get those out. Once you get those out, I want you to do two practice configurations, just like you did in the homework last night. So for this one, I only want you to do the configuration. You do not need to do the orbital notation. If that helps you to figure out the configuration, go ahead. But I just want to give you a couple of minutes to do the electron configuration, and then Miss Franks will get the video going again, and we will continue on. All right, so your electron configuration for phosphorus should be 1s2, 2s2, 2p6, 3s2, 3p3. And then arsenic, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Okay, so what we're trying to do today is we're trying to use the periodic table to figure out patterns. So by the end of class, I'm hoping that you will never need to use, or you shouldn't need to use that goofy Christmas tree looking way of writing the electron configurations, but rather you can just look at your periodic table and from that be able to write the configurations. So the first thing I want you to do is look at these two configurations, and there is something that's similar with both of them. So come up with some ideas of stuff that's similar. All right, so hopefully through this conversation you guys have figured out that both of the elements end with P3. All right, well, find these two things on the periodic table. You'll notice that they are sitting, one is sitting right above the other one on the periodic table. All right, if you look at what the third element is in this group, nitrogen, take a look at your homework. And on the homework, you're going to see that nitrogen also ends in P3. All right, so this is one pattern on the table, is that everything in the same column, or in the same family, will always end with the very same letter and superscript. All right, also from your homework, one of the other ones you did in your homework was the carbon. All right, so looking at carbon on the periodic table, it's just before nitrogen. And if you look at what it ends with P2. And then one more from your homework, if you look at aluminum, which is in the column just before carbon, ends in P1. All right, so hopefully you're starting to see the pattern. If we look across the rest of the table, we have oxygen, fluorine, and neon. And I'm betting at this point you've figured out, or maybe you haven't, that's okay, that this is going to be P4, this is going to be P5, and this is going to be P6. All right, so that big chunk of the periodic table that is 6 elements across is what's known as the P block. As you're going through those elements, if you end on any of those elements, you're going to end with P and then whatever column it happens to be in. So if you take a look at your periodic, what we can do is we can start labeling things on the periodic table. And you can just label this on the very top. Everything in that column is going to be P1, P2, P3, P4, that's a 4, P5, and then P6. All right, you might notice right away that helium doesn't quite fit into this because helium only has the 2 electrons. So I'm going to take helium and I'm going to plop it over here because when we're talking about electron configurations, helium fits a little bit better over there. All right, so we have what's known as the p block. All right, p block has 6 things across. All right, well, if you think about the other orbitals we've been working with, one of the other orbitals is the s orbital, and for the s orbital, it has 2 electrons that it can fit. And looking at your periodic table, you probably noticed that right over here we have that has 2 elements in it. This is what's known as the s block. So as you're filling in electrons over, and we have the d block. So the d block has 10 electrons. Take a look at the table, see if you can figure out where the d block is. And for those of you who said the d block was in the middle, you're right. And then finally, we also have the F block. The F block has 14 electrons in it. And if you notice, at this separate part of the periodic table, we have 14 electrons, or 14 elements. So that is what is known as the F block. All right, so we have these things blocked off. All right, let's go back to that phosphorus electron configuration for a minute. So the phosphorus electron configuration ended in 3p3. All right, so phosphorus is right here. So let's take a look at where it is. If you ever played Battleship as a kid, or maybe you still play Battleship now, this is very reminiscent of Battleship. So the p3 comes from the fact that it's in this row, so it's the p block, it's the third one over. But now let's take a look at this 3 in the front, the energy level. Well, if you look at it, if you start counting from the top down, here's the first row, here's the second row, and what do you know? That's in the third row. All right, so each of those numbers and letters you've been writing for electron configurations correspond to something on the periodic table. So what I want you to do on your periodic table, on the far left side, let's see if I can, mine's not going to let me make it any smaller. So what I want you to do on the left side is I want you to label your periodic table. So you've got 1, 2, 3, 4, 5, 6, and 7. All right, with the D block, all right, remember when you were doing the configurations for the D block, and the number for the D block didn't line up. It was always 1 less. So you would fill in the 4S, and then you'd fill in the 3D, not the 4D. Well, the reason that is because it's a lower energy level, and so you can just label your periodic table with the 4D, or sorry, the 3D, the 4D. And you just have to remember that with the D block, it's offset by 1. So whatever row it is in for the D's, it's actually in the third, if it's the fourth row. So this would be 5D. Alright, so cadmium. Put this at the top. Alright, so for cadmium, what you're going to do is, first of all, you find cadmium on the periodic table. Alright, so I'm going to end there. Now what I'm going to do is I'm going to start at the very top of the table, up here with hydrogen, with element number 1, and I'm going to write down the row, the block, and how many elements I need to go through as I get toward cadmium. Alright, so first thing is I start in row 1, and I'm starting in the S block, so there's my 1s. And for the superscript, it's how many elements you need to get through to get to the next block. In this case, it's 1s2. I have hydrogen and I have helium. Then I go to the next element, which is lithium. That's in row 2, block S, and again, there's 2 elements that I need to go through. Then I go to the next element, which is over here at boron, and I'm still in the second row, but now I'm in the P block, and there are 6 elements that I need to get through. So I go through all those. So there's my 2p6. Alright, I go to the next group, And the next group is, or sorry, the next row is row 3, and I'm back in the S block, and there are 2 elements there. And then I jump over to aluminum. That's in, again, the 3rd row, the P block, and there are 6. So I go through all those. Alright, now I'm into the 4th row, because at this point I'm over here at potassium. 4th row, S block, 2 elements, and then I keep going, but now remember how we labeled that as the 3D, so now I'm 3D. I need to go through all of them, so it's 3D10, and then the next group I get into, or the next block I get into, is the P block again, but you have to remember that the row number for the P block is the same as it is for the S, because I had gone back 1 for the D, so I've got 4P6, go through all those. Next thing is, and now I'm running out of room, 5S2, and then I keep going into the 4D, and I need to get all the way to the end, so I get 4D10. Alright, and that's my configuration for cadmium. Alright, I'm going to let you guys ask any questions of Miss Franks, and then I'm going to have you guys do another practice one, so you get the hang of it. Alright, the next one that I want you to try is yttrium, which is element Y. Alright, so I'm going to let you and Miss Franks decide if you want to have me do the example, or if you want to have some time to practice it, and then show the answer. But here's how you do it. So you'd start in the 1st row, and you're in the S block, and you have 2 elements. Then you're in the 2nd row, S block, 2 elements. So I've gone through 1, 2, 3, 4, and now I'm going to go over here, and I'm in the 3rd, oops, just kidding, not really in the 3rd row. I can't figure out how to erase things on here. I'm still in the 2nd row. I'm in the P block, and I have 6 things. And then I'm in the 3rd row. I'm in the S block, 2 elements. Then I'm over here at aluminum. I need to go through those guys, so that's the 3P6. Then I'm in the 4th row, S block, 2. I need to get all the way through the 3D, all 10 of them. Now I'm over in gallium to krypton, so I've got 4P6, and just make sure you always remember the P block is always in the same energy level as the S block, so the P and the S are the same. Alright, and then I go into the 5th level, so again I'm going to sneak it down here, 5S2. Alright, and then yttrium is my first element right there, so I have 4D1. Alright, so at this point I'm going to let you guys decide as a group if you want another practice one. If you do, I'll let Mrs. Franks figure out what she wants you guys to do, and then just pick up the video again when you are confident with that. Alright, so hopefully using the periodic table has made life easier for you, and now I'm hoping to make life even easier. So I want you to flip 2S2, 2P6, 3S2, 3P6, and that's argon. And calcium, 1S2, 2S2, 2P6, 3S2, 3P6, 4S2. Okay, so again, today's all about patterns, and finding shortcuts in how electron configurations are similar. So if you look at these 2 configurations, you'll probably notice that they do have something very similar. In fact, they are identical up until the very end. So the argon configuration is in that calcium configuration. It's just that calcium has 2 more electrons. All right, well, what we can do because of this, so we see this pattern every single time when we get to things that are at the end of the periodic table. So we get to helium, we get to neon, we get to argon, we get to krypton, xenon, and radon. These are what are known as the noble gases. All right, so we get to the end of the table, we get to the noble gases, and then we just start a new row. Well, the noble gases are unique. There's a reason why they're called noble. They're called noble because they don't react, or most of them, some of them actually do, but the majority of them do not react with any other elements. The reason things react is because they're trying to gain more stability. Well, the noble gases are already very stable elements. And because of that, we can use that in what's called the noble gas shortcut. All right, so for the noble gas shortcut, what you do is instead of rewriting the entire configuration of argon, in square brackets, and again, it needs to be square brackets so I understand what you're doing with it, so everyone's following the same convention. You can write calcium as argon 4s2. You're saying it has the same configuration as argon, and then there's a 4s2 beyond it. And you can do that with any of the elements. You just find the noble gas, one of these guys, that precedes it, and then start with that in brackets and then continue on. So for example, if I wanted to write the configuration for tungsten. Oh, actually not, I don't want to do tungsten. I'm going to, let's go with bismuth. Bismuth, element number 83. All right, so if you look at where bismuth is, you're looking for the previous noble gas, which in this case is xenon. So I have Xe in brackets. Again, it needs to be in the square brackets. And then I just jump to the next one, which is 1, 2, 3, 4, 5, 6. So it's xenon 6s2. And now you'll notice as you follow the periodic table, you've got that star. All right, well, so what the star is telling you is it's actually telling you that you need to go to the bottom of the table into the F block. So that you follow that barium is element number 56. You need to keep going with element number 57, which happens to be in the 4F. All right, so I'm going to let you guys talk about this for a little bit, and then again, pick the video up when you've made sense out of that. But we've got 4F14, and then we have to go back to pick up the 5D. So at the end of that, at ytterbium, number 70, we have to jump up to number 71. So 3D10, and then 6P3 is bismuth. Isn't that pretty nifty? All right, again, I'll let you guys decide if you need another practice one. But if you don't, we are going to move on to the next thing, which is writing configurations of ions. All right, so you need to be able to not only write neutral atoms, but also write the configuration of ions. So we're going to start with oxygen. All right, so element is going to be oxygen. So using the table, I want you to write out the electron configuration for oxygen. So you've got helium, and you don't have to write helium in brackets. You could have written 1s2, that's fine. The helium one doesn't really save you that much time. Helium 2s2, 2p4. Okay, so when oxygen forms an ion, what it does is it's actually going to gain 2 electrons, and that's going to cause it to form oxygen 2-. All right, so with those 2 electrons, when you write your electron configuration, you just need to add 2 more electrons. And if we go back to our Bohr model here, we've got 2 electrons in the first level, and then we had 2 electrons in the second, and actually 4 more in the second. All right, so I can actually fit, I can fit a total of 8 electrons in that second, so I can put those in the second level. So my configuration is now helium, 2s2, 2p6. And I'm sure somebody out there is going, hey, isn't that the same thing as writing configuration of neon? And you're right, it is. When oxygen gains 2 electrons, it has the same electron configuration as neon. All right, second example, so that's how you write an anion when you're adding electrons. Second one, let's do calcium. All right, so electron configuration of calcium, we had it earlier, it was argon 4s2. All right, when calcium forms an ion, it actually loses 2 electrons. All right, so we have the calcium 2 plus ion, plus 2 electrons is going to give us calcium. Okay, so it's losing 2 electrons. So those 2 electrons are in the 4th energy level. I'm not going to use my Bohr model just because there's going to be too many electrons in there right now for me. So, but it's going to lose 2 electrons, and it loses them from the outermost level. So my configuration for calcium 2 plus is actually just the same as the configuration of argon. All right, those two are pretty straightforward. The more confusing one comes in when we start looking at elements that fall into the middle, that fall into the D block. Okay, so let's do iron 2 plus. All right, so again, you start with the electron configuration of iron, which, looking at the previous noble gas, is argon 4s2, 3d6. Okay, so if you follow the pattern that we just did, what you're going to do is you're going to say, oh, well, I just take 2 electrons from the D block, or from that 3d. But here's the thing, and here's where my Bohr model is going to come in. So according to this electron configuration, I have 2 electrons in the 4th level, 1 electron in the 4th level, put the other one far away from it, other electron in the 4th level. In the 3rd level, I had the S and the P were full because that was on that previous row, and then I've got 6 in the D. So I have a whole bunch of electrons in that 3rd level as well. I'm not going to draw all of them, but I've got a bunch of them. Let's just say it's a whole bunch of electrons. All right, so if an electron is going to leave from the atom, you want to think about which electron is most likely to leave. And if you're thinking that it's the electrons on the outside, you're actually right. So these electrons that are furthest from the nucleus are the 2 that are going to leave. So because of that, when you're working with elements in the D block, the electron configuration of the ion is actually going to get rid of the 2 in the outermost level, the 2 in the 4th energy level. So my Fe2 plus ends up to be argon 3d6. All right, and again, I'll let you guys decide if you need another example. But after all of that, your homework is the second worksheet. And I will see you guys tomorrow.